Tripartite Tuesday, of course, okay? You guys will be able to factor by using the distributive property and discuss the test. Well, we've already discussed the test. Now time to factor by using the distributive property, okay? Did we do 3 and 4 last time or no?
Yes.
Okay, we did both 3 and 4, huh?
Yes.
Okay. So let's recap 4 a little bit here, okay? So on 4, we said, hey, they have a 3 in common, right? Now they also have an x in common, and they also had a what in common?
A y.
A y. So the lowest of each variable they had was an x to the first and a y to the first, okay? They all had at least that, okay? So then as we said, okay, well, it's 9x squared y divided by 3xy. And we said, okay, well, that's going to be 3x minus 5y was left over, right? Does that sound familiar?
Yes.
Okay, it should, because hopefully you have it written down on your paper, because we did it together, okay? Let's look down at number 5, okay? 5. Let's go through part by part. Numbers first. 40 and 20. What do we think our GCF is of this? You're what? 20. Can it get bigger than 20 for these? No, why is it? Why not? Can we stop looking after we get to 20?
Because there is no other number besides 0 at the end.
Okay, because there's no other number, so it's not like 200, something like that. Can a number bigger than 20 be a factor of 20? No. Okay, so that's the biggest it gets. Well, that's awesome. That's quite convenient, okay? So we know it's going to be a 20. Okay, now we say variables. They both have at least how many x's? X,
4.
2.
x squared. They both have at least an x squared, right?
Yeah.
The exponents, the lowest one we see for x's is 2. So that means we can pull that out.
4 minus 2.
So what about y's? What can we pull out there?
1.
Y squared.
Y squared, because they both have at least y squared. One has y squared, one has y cubed, y to the third. So the exponents are 2 and 3 on the y's, so they have at least 2 each. Does that make sense?
Yeah.
Okay. So now we have to answer the question: well, what goes inside the parentheses? Okay. What remains? So we divide each one. 40x to the 4th y squared divided by 20x squared y squared. And what is 20 divided by 40?
2.
2. X to the 4th divided by x squared. X squared, right? Because 4 minus 2. Okay. And then you don't have any y's. Okay. Plus, now we do the other one. 20x squared y cubed divided by 20x squared y squared. Okay, we are just left with a 1.
1 y.
And we just have a y, right? The x's, we don't have any. So you can write 1 y, or what could you write instead? Just y.
I get you.
I really like these. Questions on that? Okay. What's different here on number 6?
There's 3.
There's 3 things. Okay. So let's think about this one. Okay. Let's analyze this problem, and before we can start solving it, let's just think. Okay. Well, we know what is different. There's 3 things instead of 2. It's a trinomial instead of a binomial. You guys remember that? Tri versus bi.
Yeah.
3 versus 2. Okay. So we know those things. So what's going to be different as we solve it? What do we think might be different as we solve it? Let's just kind of think about that and talk about that.
There's more to divide.
Okay, there's more to divide. Okay, so at the end we kind of divided. There's going to be another thing to divide. That's true. Before we were looking at what these 2 things had in common, what are we going to have to do now?
Do it times 3.
Okay, make sure all 3 of them have it in common, right? So we have to look at all 3. So just because the first 2 have it in common doesn't necessarily mean it's something that they all have in common. No, not necessarily. So we have to look at all 3 and say, okay, 25, 10, and 15, what do each of those have in common? 5, I think, would be the biggest thing, okay? Okay, now we move on to our variables. A squared, A, and A. What? Just an A, right? The lowest one we see is an A to the first. Okay, now B's. No B, B squared, B to the first.
No B. There's no B.
Oh, no B.
There's no B.
There's none. We can't pull out anything. That was a trick question by me, okay? Good catch there, Hannah. You can't pull that out. There's nothing in the first one.
Is it because there isn't something in each and every one of them?
Correct. Yep. They all have to have it, or else we can't factor it out. Okay, so it's going to be a 5a is going to be our greatest common factor, or GCF. And then we're going to divide off to the side and say, okay, well, what is 25a squared divided by 5a? And if you think, hey, I can do this in my head, that's okay. But if you'd rather say, you know what, I better do it off the side. Okay, let's do it off the side. Not quite. 25 divided by 5 is what? 5. A squared divided by a is just a. 2 minus 1 is 1.
I didn't realize there was a 1.
Yep. You gotta be careful of those invisible ones. Okay, so let me do the next thing. 10ab squared divided by 5a. Part by part, what's 10 divided by 5? 2. A divided by a? Just 1, 0 a's left. And then you just have b squared. So plus, because that's the same symbol, 2b squared.
2ab squared?
No, but here's why. A to the first divided by a to the first. Mason, what's anything divided by itself?
1.
1. So you just secretly have like 2 times 1 times b squared, but we don't need to write that.
Okay.
Yep. And then our last one, 15ab divided by 5a, 3b. Now, do we look inside the parentheses just to double check again? 5a, 2b squared, and 3b. Do 5, 2, and 3 have anything in common?
Yes. Wait, no.
No. Okay. A, b squared, and b, do those have anything in common?
No.
No. So we're done. How could we check our work, guys?
Plug it back in.
Distribute it back in. Now let me ask this question. Had we factored out a b before, we said, can we? Had we factored out a b before, and we multiply back in, would this first term end up getting a b? If we, okay, so let me ask visually. Let me show you guys what I'm talking about. So we talked about saying, hey, can we factor out a b? Instead of a 5a, can we make it a 5ab? Well, what would happen as 5ab multiplies with 5a? It'd become 25a squared b. Does it have a b?
No, it doesn't.
No, that's why we couldn't take it out. Because as you FOIL back in, or multiply back in, you'd end up giving it a b that it never had. Does that make sense?
Yeah.
Okay, Maddie.
For the 10, like the, why don't we put a b squared and not why don't we just put b?
Like, why isn't this 2ab squared?
Mm-hmm.
Okay.
Those are a and b.
Yep. So this was, we took 10ab squared divided by 5a. So a divided by a, what's anything divided by itself? 1. So you just have a giant 1 here, so 2 times 1, which is just 2. Does that make more sense?
Yeah.
Great question. Any other question on this one, guys?
I just rushed.
Yes, good luck.
I have to use the upstairs one.
Okay. Well, let's look at number 7. Actually, I want you to try number 7.
Oh god.
When you have it or have questions, raise your hand. So number 7, what's going to be our GCF? What's the thing that everything has in it? Okay, 3. What else? 3x. Okay, so they all have at least an x to the first, and they all have at least a 3. Okay. So now we go through and we divide and say, okay, what's going to be left? So 3x to the third divided by that 3x at GCF. So what's 3 divided by 3?
X. Or 1.
Just 1, right? And then x to the third divided by x. What do we do with those exponents?
X.
Subtract, so it's x to the second. And the next symbol is plus, so we're going to write a plus sign. 6x squared divided by 3x. So 6 divided by 3 is 2. X squared divided by x, just x to the first, 2 minus 1. So it becomes a plus 2x. What's our next symbol? Minus, so our next symbol is going to be minus there, okay? Then we say, okay, well, negative 9x divided by 3x, okay? So we end up getting 3. And do we have any x's left? No, so it's just that 3. Now, if we were to distribute back in, what should we get?
The same thing as
Same thing that we started with, right? We can double check that real quick. 3x times x squared, okay, 3, 1 plus 2, x to the third. 3 times 2 is 6. X to the first, 1 plus 1 is 2. 3 times negative 3, negative 9. X to the first, no x. X to the first. So see how we can double check our work there? okay, by doing exactly what we did last chapter, okay? Olivia, does that make more sense now? Okay. Mason, does that make more sense now? All right. Let's look at number 8 near here. Now, what's different about number 8 versus our previous two? Wait, what'd you say?
It's got negative.
It's got negatives. Where's the negative at? Where's one of the negatives at specifically?
Beginning and the end.
The beginning and the end. Now, do any of these others have a negative at the beginning? No. This one had a beginning and a negative at the end. And did it really change too much? No, we just wrote a different sign. Okay. This negative at the beginning actually is going to change a little bit because here's the thing. We actually want to make that a positive somehow. So when we're multiplying or dividing, how do we make things positive when they're negative?
Add or divide.
Divide by what? Negative. What do we multiply or divided by both sides when to get a negative variable to be a positive? You guys remember? Like let's say if we had this problem, let me write up on the top left here, we have some space. The problem negative a equals 5. What would we do at this point?
Subtract or add a.
Add 5 to the
Divide.
Add 5
Negative A.
Or
Both sides.
What's secretly in front of the a?
1.
A negative 1. So what's happening with a negative 1 in a? Multiplying. So what do we do? So we divide by a negative 1. And what ends up happening is the negative a becomes a positive a, and the positive 5 becomes a negative 1, right? So what we're going to do is, since we want this negative 2a squared to be a positive, is when we factor something out here, we're going to factor it out as a negative something. Okay? So we're going to factor out as a negative something. Now, 2, 8, and 4, what do they all have in common? 2. Nothing bigger. Can't be, right? Because it can't be bigger than the smallest number. Now, do they all have any variables in common?
No, not all.
No, not all of them. The first 2 have a's, but does the last one? No. So can we take it out if not all 3 things have it? No, we can't. So it's just going to be a negative 2 that we take out. Okay, but notice it is going to be a negative because that first number is negative, and we're going to actually make that a positive, okay? It's going to make our life easier later down the road, so we're just going to start practicing it now, okay? That way later down the road, you don't have to change this habit you've built. It's just already there. Does that make sense? Okay. So once again, we're going to take everything and divide it. So what's a negative 2a squared divided by a negative 2?
A positive 1.
A positive 1. And then what's a? What about the a squared?
Nothing.
It's just a squared, right?
Yeah.
Because it's not being divided by anything, is it? So it's not changing. So it's just a positive a squared inside of there. That's what we wanted to happen. We wanted it to be positive. Okay? Lainey, we're just finishing up our 7.1 notes. And then, all right. So the next thing we'll do is the positive 8a divided by a negative 2. It's going to be a negative 4a. We solved that a. So minus 4a. So notice the sign changed there, didn't it? Okay. Oh, the last one, Hannah's saying it's going to be positive. Hannah, why is it going to be positive on the last one?
Because they're both negative.
It's going to be a negative divided by a negative. So what's negative 4 divided by negative 2? Positive 2. And that's our answer. So how could we check this, though? You could distribute it back in, right? And so we can try that. Negative 2 times a squared, well, make it a negative 2a squared. Just kind of shove them together there. Negative 2 times negative 4a, it'd become a positive 8a. Negative 2 times positive 2 would be a negative 4. So it does end up getting the same thing. And we also want to check inside the parenthesis here. A squared, negative 4a, positive 2. Do those have anything in common? No. You have a 1, a 4, and a 2 for numbers. You have an a squared, an a, and no a. Nothing in common. Okay? Any questions on that? Alrighty. So what I'm going to do is assign the rest of the worksheet. So I believe we did, what was it, 1 through 3, and then 7 through 11. Okay? So we're going to do the other 5 problems. Did you hear me? 5 problems. That's it. That's it. Okay, the other 5 problems for today. Okay, for next time, excuse me. That's it. 4, 5, 6, 12, and 13. Cool beans?
Yep.
All right. Or in Spanish, frijoles Cheetos.